This video will go over question 5 in the 2024 April exam for year 12. The first part says define gravitational field strength. So here it's important to learn the key definitions. Gravitational field strength is the force per unit mass on a small test mass. So we can say it's the gravitational force per unit mass on a small test mass. State the SI unit for gravitational field strength. Well, we know that G is F over M, so units should be newtons per kilogram. A planet orbits the Sun in a circular orbit with a period t and orbital radius r. The mass of the Sun is m. Show that t equals 4 pi squared r cubed over gm square root. So what we can do here is we can go, well, we're actually given the equation v orbital is equal to the square root of gm over r. In this case we're going to call that capital R, and v is 2 pi r over t. So we can equate these two things, so we can say 2 pi r over t equals square root gm over r. And now we want to rearrange this for t. So we can take the, in fact, just to make it a little bit simpler, we can square everything first. So we get 4 pi squared r squared over t squared equals gm over r. Just makes it a bit easier to see. And so now rearranging this for t squared, we get t squared is equal to 4 pi squared r cubed over gm, which means that t equals the square root 4 pi squared r cubed over gm as required. Okay, this equation is given in our data book that it didn't used to be, so you used to have to derive it straight from equating the centripetal force with the gravitational force. The Earth's orbit around the Sun is almost circular with a radius of 1.5 times 10 to the 11 meters. Estimate the mass of the Sun. So with this one, we can actually just use the equation that we already have and rearrange that for m. So I'll take it in this form. So we can say from this one, we can see that m is equal to 4 pi squared r cubed over gt squared, and then we note that for a full orbit around the Sun takes a year. So we can say t is equal to 365 times 24 times 60 times 60. And then we can plug this in. And we get 3.1536 times 10 to the 7. So then we get a mass is equal to 4 pi squared times 1.5 times 10 to the 11 cubed over 6.67 times 10 to the negative 11, which is g. and then times t squared, and t was, what was it? What did I say? 3.1536 times 10 to the 7. 3.1536 times 10 to the 7 squared, and that gives us, so let's go 4 times pi squared times 1.5 times 10 to the 11 cubed divided by 6.67 times 10 to the negative 11 times 3.1536 times 10 to the 7 squared, which gives us 2 times 10 to the 30, or 2.00 times 10, oh actually we only need two significant figures, 10 to the 30 kilograms. Okay, so that's the end of the standard level paper. There are a few more questions in the higher level paper.